Alright guys, Brandon Lee here. We're going to talk a little bit about low Earth satellites. Now that seems like a topic you really wouldn't care about. When do you need to think about satellites around the Earth? I mean, you're busy enough on the Earth. Why think about the sky and the stars and all the things that we put up there? Well, the answer is they actually have a lot more to do with everyday life than one would think. Not only is our entire communication system reliant on satellites, experiments and things have been going on with everyday objects, not some huge NASA program that are actually experiments of low Earth satellites themselves with ordinary things like baseballs, things like that, bullets. Now I'm going to show you a little bit more about it. Just a basic overview of low Earth satellites 101. Let's take a look. So low Earth satellites, about 2.5, 3 minute crash course. Let's just say, for example, you're on the beach here, and let's just say, for example, you're on the beach here, and this is the coastline. Here's the sand, sandcastle, some lawn chairs, things like that. Well, you're on the beach, and you look out, and it's not going to be to scale, but 8 kilometers out, and here's you looking into the sea. 8 kilometers out, there's a ship. Just right here. And it has a mast of 5 meters. So you should be able to see that. So this ship here, the mast is 5 meters tall. Now I'm telling you, these drawings are not to scale. But let's just pretend that this is happening. You're looking up. Because the Earth is a curve, and it's kind of tough to draw like this, his vision is actually going to curve. Now let's just say someone standing right here should be able to look straight at the ship, right? Well, their vision will curve, so they will only be able to see the top of the ship. That's because the Earth, every 8 kilometers, you would travel. Let's say you're walking, you would drop 5 meters. Okay. Now, Newton used this theory back ages ago. Let me just adjust the camera. Back ages ago to propose that if you were to send something around the planet, let's just say that this is a planet Earth, and you were to send something around the planet at 8 kilometers per second. Now let's remember that the acceleration due to gravity is 9.8 meters per second squared. That's getting closer to the Earth. But say when you're on the Earth, for that first second, we're going to use 1/2 AT squared. Now for the first second, let's say at 1 second, time equals 1 second, that very first acceleration is going to be 1/2 the 9.81, 1 second. And that's falling down. So your acceleration is going to be roughly 5 meters downwards. Now remember what we said, the curve of the Earth every 8 meters drops 5 meters. And I'm sorry, 8 kilometers drops 5 meters. So it's safe to say that in the first second of traveling 8 kilometers, you're only going to drop 5. And since you're not getting closer to the Earth like this, you're only going, around the Earth, that acceleration is actually going to stay the same at 5 meters per second. So it's safe to say that if you were to launch, let's say you are in this little tower here. It's the tallest thing on the Earth. There's nothing to block it. Let's just say there's no air whatsoever. All the air of the planet's gone. You shoot something over at 8 kilometers per second, which is insane.